right, so this is 7.1 part 2, and we're going to be talking about radians. So to define what a radian is, it's a central angle. It's a positive angle whose vertex is at the center of the circle. The rays of the central angle subtend or intersect an arc on the circle. If the radius of the circle is r, then the length of the arc subtended by the central angle is also r. Then the measure of the angle is 1 radian. So if you look at this figure here, and I'll once again star it so you know which one I'm looking at, we can see that the length of the radius and also this little piece here is also r. So that's the arc. That's what a radian is. We can also make it bigger. So if the radius is 3 instead of 1, then that arc length here should also be 3. And by the way, radians in general will have pi involved. And this is a generalization, but usually you're going to see pi over 4, for instance, pi over 3, pi over 2, pi over 6. And we're going to see that these radians have their degree counterparts. So for instance, pi over 4 is equal to 45 degrees. And we're going to have a conversion that you can use, a formula, or you should probably memorize stuff like that, but we'll get there. So objective number 2, find the length of an arc of a circle. And so what we're looking for is how long this piece S is. So there's an arc length theorem that comes up with this formula that S equals the radius times the angle. So the radius is denoted with the letter R, and the angle is, in this case, theta. Now, theta has to be in radians. If it's in degrees, that means you have to convert it. So once again, if the arc length theta, and theta is this little symbol here, is in degrees, you have to convert it to radians. And I know we don't know how to do that quite yet, but we're going to learn. So, for example, you'll get a problem that you're going to find in your homework. It says, find the length S of an arc of a circle with a radius 50 inches subtended by the central angle, which is 1/10 of a radian. So if I'm looking for the length of the arc of the circle, I know I have to use this formula, S equals R times theta, where R is the radius, and the radius they told us is 50 inches. And we also know that the angle is in radians. The central angle is 1/10. So if I put this into the formula, S equals R, remember R is 50, and the angle is 1/10. So 50 times 1/10 is 5. And we're in inches. So that arc length is going to be 5 inches long. Okay, we're now on objective number 3, converting from degrees to radians. So here's just an important bit of information. 1 revolution is equivalent to 360 degrees, which is also equivalent to 2 pi radians. So half of a revolution is 180, so that's equal to half of that 2 pi, which you get just pi. So 180 is equivalent to pi radians. So here's the 2 conversion formulas. If you want to go from degrees to radians, you have to know that 1 degree equals pi over 180 radians. Where did I get that? I just take this formula right here, and I get radians by itself. I divide it by pi. So 1 radian is going to equal 180 over pi. We can go the other way around as well. If I want in degrees, so I want degrees, I just take and divide by 180. So I get pi over 180 radians equals 1 degree. Okay? So once again, 1 degree equals pi over 180 radians, and 1 radian equals 180 over pi degrees. If you want your answer in radians, then you'll want to have pi in the numerator. See? Pi is in the numerator. If you want your answer in degrees, then you want to have pi in the denominator. So let's go ahead and do this. Convert each angle in degrees to radians. So if we look at part A, we have 30 degrees. Okay, so I start out with 30 degrees over 1. And remember, I want this answer in radians. So if I want my answer in radians, I use pi over 180. Once again, pi is in the numerator, okay? And now I want to do is I want to reduce this down. Okay, so I know that 30 goes into 180 6 times. So I'm going to reduce this down, so 1 over 6. So I get 1 times pi, which is pi, and 1 times 6, which is 6. So 30 degrees is equivalent to pi over 6. By the way, this is something that you will want to memorize. Okay? So let's look at B. B asks us to find 210 degrees. So once again, 210 over 1 times pi over 180. And we are going to reduce this down as well because I know that at least 3 goes into both 18 and 21. So if I use 3 as a reducer, I get 70 here, and 3 goes into 180 60 times. And furthermore, I can get rid of these zeros, so I have 7 and 6. So when I multiply that together, I get 7 pi, because 7 times pi is 7 pi, over 1 times 6, which is 6. So 210 degrees equals 7 pi over 6. Okay, I'm going to be erasing this, so if you need time to write this down, pause the video and do that, and then start it up again. So I'm going to do C and D because C asks me to do negative 225 degrees. So once again, I'm in degrees, I want to be in radians, so I do pi over 180 degrees. I know that 180 is divisible by 45, as is 225. So 180 divided by 45 is going to be 4. 225 is going to be 5. 5 times 45 will give me 225, so that's how I got that. So now I have negative 5 times pi over 1 times 4. So we can state that negative 225 degrees is equivalent to negative 5 pi over 4. If you didn't use 45 and you used 5, that's fine. Keep on reducing down. And finally, part D says 90 degrees. So we have 90 degrees over 1 times pi over 180. And this one's a little bit easier because I know that 90 goes into 180 twice. So I'm going to use 90 as a reducer. So 1 times pi is pi over 1 times 2, which is 2. So 90 degrees is equivalent to pi over 2. So these are conversions that you're going to need to memorize because we're going to be doing what's called a unit circle in a little bit, and you're going to have to graph out the unit circle, so you have to memorize these just to make the process a little bit faster. So here's the deal. 30 degrees is equivalent to pi over 6. 60 degrees is equivalent to pi over 3. 90 degrees we just did, which was pi over 2. 45 degrees is pi over 4. And 180 degrees is pi. 270 degrees is 3 pi over 2. And finally, 360 degrees is 2 pi. So your homework, besides actually doing homework in the homework system, is to memorize these, okay? So 30 degrees, pi over 6, 60 degrees, pi over 3, 90 degrees, pi over 2, 45 degrees, pi over 4, and 90 degrees equals pi over 2. And then finally 270, which is quadrant angle, is 3 pi over 2, and 360 is 2 pi. I just wrote this out a little bit neater for you because there's more room over here. Okay, so these ones, memorize them because we're going to be adding more to those. But you'll notice that we have the quadrant angles in there. And I put 90 degrees down there twice, so let's just fix that. Let's put 180 degrees here and put in pi. So the quadrant angles are 90 degrees, 180 degrees, 270, 360. And by the way, 0 degrees is going to be 0 radians. So that would be the answer for that one. Okay. Converting from radians to degrees. So now we're working backwards. We're starting with radians and we want to get rid of pi. So we need to know the conversion that pi has to be placed in the denominator. In the denominator. Okay. And the reason why I want it in the denominator is I want to be able to cancel it out. So let's check this out. We start with pi over 6. And if I want to go from radians to degrees, I want to use 180 degrees over pi. And once again, the pi's will cancel each other out. Okay? So that's what you want them to do. So let's go ahead and reduce this down. Pi over 6 times 180 over pi. So the 2 pi's cancel out. 6 goes into 18 3 times. 6 goes into 0 times. So I'm left with 1 times 30, which is 30 degrees over 1, or just 30 degrees. For part B, I start with 3 pi over 2, and I'm going to multiply that by 180 degrees over pi. So once again, the pi's are going to cancel each other out, and then we have to reduce some things down. So let's get rid of the pi's. And 2 goes into 180 90 times. So I get 3 times 90 degrees over 1. 3 times 90 degrees is 270. So 3 pi over 2 is equivalent to 270 degrees. C asked me to do negative 3 pi over 4. So once again, I want my answer in degrees. So I'm going to put pi in the denominator. So now we're going to reduce some things down. I know that 4 goes into 180 evenly because if you break not a 180 in half, you get 90, and half of 90 is 45. That's how I knew that. So 4 goes into 45 4 times. And the pi's will cancel each other out. So I have negative 3 times 4 over 1. And negative 3 times 4 is going to be, and it should say 40, sorry, that's what's the problem. Negative 3 times 40 is negative 120 degrees. And that's the answer for this one. Okay, and now we have D. D says we have 7 pi over 3. And once again, I want my answer in degrees. So I'm going to cancel some stuff out. I'm going to get rid of the pi's. And 3 goes into 180 60 times. So I get 7 times 60 degrees over 1, which is 420 degrees. All right, and let's do E. E says 3 radians. So this one's kind of weird. So once again, I'm going to take that 3 over 1 times 180 over pi. And you'll notice this time around that we don't have the ability to cancel out the pi's, but we still have the right formula. So I'm going to take 3 times 180, and I'm going to divide that by pi. So 3 times 180 is going to be 540. And it's going to be over pi. So this is the exact answer. On your calculator, you would need to divide it out and it would give you an approximation. But I'm going to leave my answer with pi in it. Okay, so that's how you do A through E. And on the bottom of the page are some lists of famous conversions. For instance, 0 degrees equals 0 radians. So I told you guys to memorize that one. And I told you to remember that 30 degrees equals pi over 6. 45 degrees equals pi over 4. 60 degrees is pi over 2. 90 degrees is, 6 degrees is pi over 3. I think I said pi over 2 on accident, but at any rate, 90 degrees is pi over 2. And then we have these other values here. And so I want you guys to notice something really quick. With the 30-degree measurements, it's going to have a 6 in the denominator. They don't match up. So pi over 3 is not 30 degrees. Pi over 6 is. And 60 degrees has a 3, pi over 3 as its radian conversion. Remember, it doesn't match up. So 60, there's not a 6, it's a 3. And 45 degrees always has a 4 in the denominator. So if we look at the rest of these, 120, and also let's do all the ones with 3 in them. So I'm going to circle these. So anything with the 3 in the denominator is based off of the 60-degree measurement. So 120 is 2 pi over 3, 240 is 4 pi over 3, 300 is 5 pi over 3. Now let's look at all the ones with the 6 in the denominator. So if it has a 6 in the denominator, it's based off of the 30 degrees. So 150 is 5 pi over 6, 210 is 7 pi over 6, and 330 is 11 pi over 6. All the ones with 4s in the denominator, 3 pi over 4, 5 pi over 4, and 7 pi over 4. These all relate back to the 45-degree angle. So 135 degrees is 3 pi over 4, 225 is 5 pi over 4, and 315 is 7 pi over 4. This will become more apparent when we do the unit circle, but I just wanted to point that out. So once again, the ones you need to memorize right now are the ones I'm highlighting. So 0, 30, 45, 60, 90, 180, 270, and 360. Those are the ones that you need to memorize right now. Okay, so this brings us into another section, Objective 4, find the area of the sector of the circle. This is pretty easy. This is on the first test, okay? So this will definitely be one of the questions that you might get. To find the area of a sector of a circle, you take 1/2, you're going to take the radius and you're going to square it, and you're going to multiply it by the central angle, which, by the way, has to be in radians. If it's not, you're going to have to convert it to radians, okay? And we just learned how to do that. So let's go ahead and look at that. So area means exactly that. We're finding the area of this whole entire angle inside of this circle. So we're finding this piece of the circle. So that's called a sector. All right, so we're going to use the formula. So let's look at the example. Area denotes the A equals the area of the sector of a circle of a radius r formed by the central angle theta. Find the missing quantity. The radius is 4 inches. Theta equals 90 degrees. What is the area? So we're going to use the formula. Area equals 1/2 r squared theta. We know that r equals 4 because they tell us in the problem, and that theta equals 90 degrees. Remember that this has to be in radians. Okay, hopefully you remember that 90 degrees is equivalent to pi over 2. But if you don't, then go ahead and do the conversion. Remember, if you're turning to radians, pi has to be in the numerator. And you do 90 degrees over 1 times pi over 180 degrees and reduce it down. So this equals pi over 2. So remember that you're supposed to memorize that. I had to change it to radians because the formula is in radians. So now I'm going to plug everything in. 1/2 times 4 squared, because that's what the radius is. And then the angle in radians is pi over 2. So this equals 1/2 times 16 times pi over 2. So we could write this out as 16 pi over 4. And that'll allow us to reduce this to 4 pi. Now it should be in inches squared because I took the radius, which was in inches, and squared it. So 4 pi inches squared is the proper answer. Now it's asking you to round to 3 decimal places as needed. So when it says that, you can try to plug that into the homework system, and if it doesn't work, what you're going to do is go on the calculator and multiply 4 by pi. So 4 times pi, and you're going to use the actual pi symbol. It's taken me a moment to find it on my calculator here. And that's going to give me 12.5663. And let me write that over again. The pen didn't look too nice. So 12.56637. Now it says to round to 3 decimal places. So 12.566 inches squared, or squared inches, would be my answer. That's equivalent to 4 pi. On the test, you will not be allowed to use a calculator. So on the test, an answer that would be fine with me is 4 pi. Okay? All right. So with that being said, we have finished out for 7.1. Congratulations. Next video that you'll need to watch next week is 7.2. Have a good day.